Volcanic eruptions are powerful geological events that involve the release of magma, gases, and ash from beneath the Earth's crust. Here's an overview of the science behind volcanic eruptions in 8 to 10 short paragraphs. Magma formation. Volcanic eruptions begin with the formation of magma, molten rock that forms beneath the Earth's surface due to high temperatures and pressure. Magma is generated in the mantle and crust through processes such as melting of rock due to high temperature, decompression melting as tectonic plates move apart, or the addition of volatiles, water and gases, that lower the melting point of rocks. Magma composition. The composition of magma varies, influencing the type of volcanic eruption. Magma can be classified into basaltic, low silica content, more fluid, and acidic, intermediate silica content, or rhyolitic, high silica content, more viscous. Viscous magma tends to trap gases, leading to explosive eruptions, while fluid magma allows gases to escape more easily, resulting in less explosive eruptions. Volcanic vent and conduit. As magma rises towards the surface, it collects in a magma chamber beneath the volcano. The magma then moves upward through a conduit, a channel that connects the magma chamber to the surface. The vent is the opening through which volcanic material is ejected during an eruption. Types of volcanic eruptions. Volcanic eruptions are classified based on their explosiveness and the type of volcanic material ejected. Effusive eruptions involve the relatively gentle release of lava flows from the vent, common with basaltic magma. Explosive eruptions eject fragmented magma and gases explosively into the air, producing pyroclastic flows, ash clouds, and volcanic bombs. Factors influencing eruptions. Several factors influence volcanic eruptions, including the composition and temperature of magma, the presence of gases, such as water vapor, carbon dioxide, and sulfur dioxide, dissolved in magma, and the geometry of the volcanic conduit and vent. These factors determine whether an eruption will be effusive or explosive. Volcanic hazards. Volcanic eruptions pose various hazards to surrounding areas. Pyroclastic flows, fast-moving currents of hot gas, ash, and rock fragments, can travel at high speeds and devastate everything in their path. Ashfall can affect agriculture, infrastructure, and air travel, while lava flows can destroy property and infrastructure in their path. Monitoring and prediction. Volcanologists monitor volcanic activity using seismometers to detect earthquakes caused by magma movement, gas emissions, ground deformation, and thermal imaging. This monitoring helps predict volcanic eruptions and issue warnings to minimize the impact on communities. Volcanic impacts on climate. Large volcanic eruptions can inject significant amounts of ash and sulfur dioxide into the stratosphere, where they can persist for months to years. This material reflects sunlight back into space, temporarily cooling the Earth's surface and leading to short-term climate cooling effects known as volcanic winter. Volcanic landforms. Volcanic eruptions create a variety of landforms, including volcanic cones, calderas, lava plateaus, and volcanic islands. These landforms contribute to Earth's geology and shape landscapes over millions of years. Volcanic activity and human history. Volcanic eruptions have influenced human history and cultures worldwide. They have shaped landscapes, provided fertile soils for agriculture, and created natural resources such as geothermal energy. However, eruptions can also cause significant disruption and tragedy, requiring preparedness and response measures in volcanic regions. In summary, volcanic eruptions are dynamic geological events driven by the movement of magma from beneath the Earth's crust to the surface. Understanding the science behind volcanic eruptions is essential for assessing volcanic hazards, predicting eruptions, and mitigating their impacts on human populations and the environment.